All right, textbooks over to page 198. Good to be back with people in the room. Yesterday morning, I recorded that lesson for you, and I have to say, it just feels weird trying to teach to empty chairs. So, the good news is, if you had questions today, we can get them answered. And we're going to start by looking at something that I think we should be fine with, and that was the bottom part of the homework. Page 198, the review section. Basically, we just skipped number 8. Number 1, is it a function, yay or nay, class?
No.
Nay, it is not a function. Number 2, yay or nay?
Yes.
Yay, it is indeed a function. That is what shape, by the way? Parabola, but it's an inverted parabola. So the equation, remember, is going to be or the function rather is going to be a quadratic function with that negative good in front of the x squared. Number 3, is that equation a function? What did you determine on that? Brandon?
I had no.
No, because when you get the y by itself, I would double switch, right? 7 to 25 over is a negative. Divide away the 9, take the square root, and that's the key right there, is when you take that square root, we get the positive negative there. And so not a function. What about number 4? Function or not a function, Abby?
Yes.
Yeah, I've got function there also. We've got a couple of y cubes. I'm going to get the y cubes together. So keep the 6y cubed. Bring the 4xy cubed over as a positive. And we can ditch the 9x as a positive as well. So going to something like this, factor out the y cubed. I get 6 plus 4x. Of course, we can divide that away. And then finally take the cube root. But remember, a cube root doesn't get a positive negative. Only even roots get positive negatives. So yes, that is a function. Any questions 1 through 4? And that kind of goes back to last test even, but any questions there? All right, now for the functions we were working on. They wanted you to find f minus g of x. For number 5, what did you get? Audrey?
Negative 5x squared plus x minus 6.
Good, negative 5x squared, positive x, negative 6. Number 6, what did you get, Genesis?
6x squared plus 7x plus 12.
Good, 6x squared, positive 7x, positive 12 is correct. Number 7. Now, you can tell me thank you for letting you off the hook on number 8. Okay, because number 8 had to be quadruple distribution. At least number 7 was only triple distribution.
Wait, what?
But it was still nasty. Finding fg of x with a 4-term polynomial and a trinomial. And there was a gap in the multiplication. This is nasty. Speaking of nasty, let's go to Michael for our answer. Michael, what did you get for number 7, fg of x?
18x to the 6th, negative 150x to the 5th, positive 510x to the 4th, negative 483x cubed, negative 66x squared, positive 342x, negative 45.
And how many got the same answer as Michael? Well, several of you did. A lot of places he could have messed up and he didn't. In case you couldn't hear the answer, even though I wish I could just say whatever, you should have heard him. He was right next to the camera. 18x to the 6th, negative 150x to the 5th, positive 510x to the 4th, negative 483x cubed, negative 66x squared, positive 342x, negative 45 was your answer. All right. Number 9, f over g of x. What did you get for that one, Maddie? Good, x negative 1 where x cannot be 5. And number 10, Kendall?
X plus 12 where x cannot equal negative 3.
Great job. X positive 12 over x cannot equal negative 3. So other than number 7, which is just, yeah, the rest of it I didn't think was too bad there. Any questions on the last part of the homework there? Any questions on that? How many, other than maybe a small mistake somewhere on number 7, because there were a billion places you could have messed up, feel like you handled the bottom half, the review section, just fine. All right, any questions? All right, now let's look at what we were talking about yesterday. And the domain thing is what going to be the emphasis of the lesson today. So I'm not even going to address the domains as I go over the homework right now. What I want to focus on is, can we find f of g of x, g of f of x? All right? So for number 1, first of all, we remember 1 through 9, the teal problems. Number 1, they gave us f of x is the 3x plus 5. They gave us that g of x is 4x squared plus 6. And they wanted 2 answers for each of these. So number 1, they first of all wanted f of g of x. My first step is going to be to rewrite this as f of what, Kendall?
G of x.
So f of
4x squared plus
4x squared plus 6, which means, class, I'm going to plug in 4x squared plus 6 into the f function wherever I see x. So, Kendall, how do I rewrite the f function?
3 times 4x squared plus 6 plus 5.
Good. And then to simplify, all I have to do is, and I end up with
12x squared plus 18
plus 5, so 12x squared plus 23 should have been your final answer. How many had that for f of g of x? Okay, most of us. Good, that's a good sign. All right, and then for g of f of x, again, I'm going to start by rewriting this as g of what, Maddie? 3x plus 5. Which means in the g function, I'm going to rewrite it so that instead of an x right here, I've got a, well, instead of an x, I'm going to put 3x plus 5. So what do I write out? No. We're in the g function, right? G of this. So times all right, does that make sense? Everything here stays the same. It's the g function, so it's a 4x squared plus 6, but literally, instead of the letter x, I just replace it with the binomial 3x plus 5. Does that make sense now? Again, one of the things that I wish I could have seen yesterday as I was teaching it, and it's like, well, hopefully they catch on because I can't tell if they're going to get it or not. But again, that's what today is for, is to backtrack, make sure we're good to go. So then from here, Maddie, if I wanted to simplify, what would I need to do? Let me move this out of the way. We're going to do it for a little bit anyway. Other way around, remember, exponent before multiplication. And of course, we're going to keep the plus 6. All right, now, all right. And since we're going to also add a 6, we'll just say 106. How many had that for g of f of x? All right, good. Maddie, does it make more sense now that you've had a chance to try one? A little bit? I'm going to stay with you, not because I want to pick on you, but I sincerely want to help you. So number 2, we've got an f of x is x squared plus 2, and g of x is x negative 7, and they want us to find, first of all, f of g of x. Again, the other way you might see this is f of, and then in the parentheses it'll say g of x. This means the same thing as a reminder from yesterday. All right, so Maddie, what should I write? F of, good. All right, so that means I'm going to copy which function? The f function, but I'm going to replace all of the x's, I mean there's only one, I'm going to replace all the x's with x negative 7. Just like if we said f of 3, Maddie, we'd replace the x with a 3 and say 3 squared plus 2. Well, it's f of x minus 7, so I'm going to say x minus 7 squared plus 2. And that's my next step, is to write out the x negative 7 squared plus 2. All right, then from there it's just simplification. Genesis, I'm going to square the binomial. But I'm going to add the 2 to the 49, so let's make it. And there we go. All right, so then after that, they said, okay, we want g of f of x. And so back to Maddie here. I think we're just about there. I'm going to say g of f of x becomes of, good. Well, I'm going to use this function because it wants the g function, but I'm not going to write x negative 7. I'm going to write, good, x squared plus 2 negative 7, or in other words, just And there we go. All right, how many of both of these correct on number 2? You got part A and part B correct. All right, any questions on that? All right, Michael, let's go to you next. On number 4, we had f of x equals negative 3x squared negative 9. G of x is a square root of negative 4x positive 8. Wanted to find f of g of x. How do I write it out?
Negative 3 times the square root of a negative 3.
Well, I like to start with the f of square root of negative 4x plus 8. But then, yes, we've got
Negative 3 times the square root of negative 4x. I forgot the rest of the thing. Negative 4x plus 8, yeah, squared. Plus minus 9.
There we go. Okay, again, just replacing the x with the other function, and then
you use the square to eliminate the square root, and you get 3 times 4, which is positive 12. Or you can write it down.
okay, sorry.
Positive 12x, negative 24, minus 9, it's negative 33.
And there we go. And then for the other half was g of f of x. And Genesis taught me how to write this out. Finish moving that out of the way.
You would do G times
G of.
negative 3x squared minus 9.
All right. I'm going to come down instead of next to. Okay, so that becomes
Negative 3x squared
all right, which function am I in?
G.
The g function, okay.
The square root of negative 4x plus.
Well, not x.
Oh, negative 4 times negative 3x squared minus 9 plus 8.
There we go. And I do need to simplify inside the radical here.
Positive 12x squared, positive
36. And then if we add 8 more to the 36.
44.
And there we go. And we get both of these correct on number 4. This one a little harder because we had the radical in there. Okay, a couple people dropped off there. Questions? All right. Number 5. Got f of x is equal to 8x positive 11. And got g of x is equal to 1 over a negative 2x plus 12. We got f of g of x. And let's go to Audrey.
We'd have 8 times.
Let's start with f of g of x. So f of,
1 over negative 2 plus 4.
all right.
So you'd have 8 times 1 over negative 2 plus 12 plus 11.
But anytime there's something being multiplied by a fraction, that something could just move into the,
The numerator.
so really it's 8 over negative 2x positive 12 plus 11, but I'm not going to leave my answer like this for a couple of reasons.
You can pull out a 2 and then cancel.
I can pull out a 2 and cancel that with the 8, but I should also pull out the negative and slide that to the front. So if we make this a negative 2 that we factor out, leaving us with,
x plus a negative 6.
then our final answer could be
Negative 4 over x minus 6 plus 11.
there we go. And that's the best way to leave the answer for the first part of number 5. Let's stop there real quick. Any questions on that? All right, how many got that answer? Okay, only a couple. Okay, a few of us got it. All right, those who didn't, it's making sense now. Okay, again, a little bit of reducing and then factoring out the negative, some technical minor things to worry about there as well. All right, and then the back half was g of f of x. And Brandon, let's start by writing
g times
Of
a g of 8x plus 1. And we found the x, so 1 over negative 2 times 8x plus 11 plus 12.
all right.
And then I distributed so 1 over negative 16x minus 22 plus 12.
Okay.
And then I combined the terms to get 1 over negative 16x minus 10.
And then little technical thing we ought to do.
Pull out the negative.
Slide it all the way to the front, and we're left with
1 over 16x plus 10.
there we go. That's the best answer. If you got this answer, minus a point, but this is the answer we're shooting for there. How many had that? Anyone get the answer right before? Just forgot to pull out the negative. All right, questions. Maddie, as you've continued looking at these, continue to make more and more sense to you? Ish. Okay. We'll come back to you here in another minute. Let's go to Abby, though, on number 8. And these look like a little bit more normal functions again. We had the f of x is equal to negative 5x plus 10, and the g of x, negative 6x squared, negative 8. They sure like negatives in these ones. All right, Abby, f of g of x. Walk me through.
F of negative 6x squared negative 8 equals, sorry, I just blanked.
Well, which function are we looking at?
F.
All right, so we're going to copy the f function,
yeah.
but with a change.
Yeah, negative 5 times negative 6x squared negative 8 plus 10. And then distribute to get positive 30x squared, positive 40, and plus 10, so positive 50.
And there we go. And that worked out really nicely for us. And then we want the g of f of x. Let's go back to Kendall.
G of negative 5x plus 10, and then negative 6 times negative 5x plus 10 minus 8.
Ooh, careful.
No, squared.
Squared. Yeah, don't lose anything, just the x itself. Not the x squared getting replaced, but just the x. So that means we're going to have to...
Square negative 25.
Good.
Squared. Positive 100. Nope, negative 100.
I know, it messes with you, doesn't it?
Positive 100.
And of course, minus the 8. Now,
And distribute.
6 quarters.
150.
Yeah, $1.50, right? For 6 quarters, 4 for the $1, 2 for the 50 cents. So negative 150x squared.
Positive 600x. Negative 600.
And then subtract 8 more.
500. Nope.
Is negative 600, negative 8, negative 600. And there's your 2 answers for number 8. And then we get both of those. All right, good. Several of you questions. All right, and let's see, number 9, we come back to Maddie on this one. And f of x is a big, ugly radical. Not like, anyway, we'll stay out of politics. All right, and then g of x is negative 3x squared, negative 9. Maddie, we wanted to find f of g of x. Walk me through.
F of negative 3x squared negative 9.
Let me make sure this is showing up on the camera. It's not quite, okay? I think I might have cut something off earlier, so I'm sorry for those watching on YouTube. All right. Continue.
Negative 3 times 2 squared.
Now, which function are we looking at? Keep everything but the x. Right, so everything about the f function, remember, is going to stay exactly like it is. Square root of negative 2x, positive 12. It's just instead of x, we're going to drop that right in that spot. All right? Then it's algebra. There we go. All right, and then if I wanted g of f of x, let me erase the rest of this richer way. Left it from earlier. All right.
G of square root of -2 plus 12.
Oh, sorry. I erased the x earlier to make a point, but yeah. All right. Good. All right. Then
-3 times -2x plus 12 minus 9. And then distribute and get the 6x. -36 minus 9. And then 6x. -20. Positive. No. There's no. 45.
And there we go. How many of those answers for number 9? Okay, just a few of you that time. All right, questions on this. Again, yesterday I didn't get a chance to see a single facial reaction to see if you were catching on to any of it. It was just kind of a, gee, I hope they're doing okay with this. You know, I hope they'll do okay. I guess, yeah, give them my best explanation. But does it make better sense now that you've seen it? Even if you got most of them, are the questions on this still? All right, now the big confusing thing yesterday is domain, right? What's the domain? And here's kind of the idea, is f of x has some sort of domain all of its own, correct? And g of x has a domain all its own. F of g of x has what would appear to be its own domain. But really, because it's a composed function, its domain is the aggregate of its own apparent domain, g of x's domain, and f of x's domain. For instance, you have your own genetics, right? But that doesn't make them separate necessarily from your parents. Your parents' genetics certainly have a part of what you are, right? Both of them, right? So it's like, pretend these are like what we might call these the parent functions. Well, they've got their DNA, we'll call it the domain. And then this function, yes, it's its own function, but because it came from these, it is the offspring, if you will, if we want to continue that analogy. Its DNA has what you see on the surface, its own domain that you would see, but we also have to account for the others. And we're going to take every limitation that presents itself and put them all into a single domain. That's kind of what we're going to work on today. So next section in your notes, we'll actually make this a whole separate section because I think that'll be easier for you. Domains of composed functions. Domains of composed functions. What we're going to do for each of these is, for each parent function, we're going to list its domain. For the resulting function, we're going to list what I'm calling the apparent domain, the domain that it appears to have. We're going to draw a number line for each one. And we're going to take all the limitations, and I think the number line will help us visualize the actual domain that we have. Write this function down. Let's suppose we start with a function f of x, and it's x squared plus 3. Let's take a function g of x is square root of x negative 7. We want to find f of g of x. All right, before you begin, let's find the domain of the parent functions. What is the domain of a quadratic function class? All real numbers. Plug in anything you want. All right. let's find the domain of this radical function. 7 is the smallest number you can plug in. You put in anything smaller than 7, you're going to go negative here, right? 7 to infinity. Now, let's actually find f of g of x. So again, the process here, f of what class? Square root of x negative 7, which means we go back to the f function, and instead of x squared plus 3, it's square root of x negative 7 squared. Plus 3. When you square a square root, you get the radicand. So that's just going to be x negative 7 plus 3, or in other words, x minus 4. All right, this is the function that I'm looking for. So this is my first answer. But part of the answer is the domain. Now question, what does it appear that the domain is right now? Oh, no numbers, right? There's no limitation. This is a linear function. It has no limitation on domain or range. That's what it appears to be. But that's not its domain. If I were to draw a number line for each of these, if I were to graph, for instance, let me get some little pink chalk here. All real numbers, of course, let me break the pink chalk. I was about to make a Valentine reference because of the pink. I'm like, well, that would be broken heart then. Okay. Big piece, little piece. All right. All right, so all real numbers, that's the first one. The next one, okay, if we call this 0, maybe right around here is 7, that's the domain of the next one. All real numbers, of course, would be this. Well, there's only really one limitation here, isn't there, class? So if we have to count for every limitation, this is the only one. Here, it looks like you could plug in anything you want. Here, you can plug in anything you want. Here, you can only plug in from 7 upward. Then that's all I can plug into this function. So my actual domain here is going to be 7 to infinity. And that's the full answer. F of g of x is x negative 4, but your domain is between 7 and infinity. You can't actually plug in anything else. So again, on the surface, it looks like, well, I could plug in a negative 16. No, you can't, not into f of g of x. If this were a standalone function, if it were its own thing, sure. But because it was made from 2 existing functions, it carries all the limitations that the earlier functions had. They had their own limitations. Your parents had their own genetics. All kinds of flaws. I could tell just... Okay, I'm not going to go there. But anyway, right? Any whatever genetic traits were in your parents' DNA, that's in yours now too. Well, these were part of the parents' DNA. It's part of its DNA as well. Does that make sense? Again, it's not a perfect analogy, so we don't run too far with that one, but does that make sense there? All right, make sure you got this down. Let's reverse it now and find g of f of x. G of f of x. Again, in just solving the function, we're going to say g of class x squared plus 3. So I'm going to look at which function? G of x, and I'm going to replace the x with, and then minus 7, which is going to give me the square root of. Now this is an interesting one. There's 2 ways to approach this. There's the logical approach, and there's the math approach. Can I plug in a 0? That would leave me with a negative, wouldn't it? Can I plug in a 1? 2? Yeah, I can plug in a 2. What about a 3? 4? 5? But I can also plug in negatives, can I? Can I plug in a negative 1? Negative 2? Negative 3? Negative 4? Basically, again, if we were to say, okay, the x squared minus 4 has to be positive, right? Because it's the radicand, looking this way. This radicand has to be positive. It must be greater than or equal to 0. Then that means that x squared must be greater than or equal to 4, which means x must be, quote unquote, greater than or equal to positive negative 2. But remember, for a quadratic, those are separator points. So on this number line, I'm either in between the positive negative 2 or I'm outside the positive negative 2. Remember, 2 separator points, 3 ranges. And we deduced 2, 3, 4, 5, 6. That's all cool, right? Negative 2, negative 3, negative 4, negative 5, negative 6. That's all good. but -1, 0, +1, no good. So again, if this is 0, from 2, upward I'm good. From -2, downward I'm good. The question is, what if you put the aggregate of all of this together? Well, here's the problem. Obviously, it can't be everything, right? Because from here over is a big no-no. But the same thing's true down here. From here down, it's all a no-no. Even though this function would seem to allow a little bit here, and then all of this, this function is really, really limited. This is if you have one weird parent. Don't raise your hand. All right? But this one is really limiting what we can get. We can still only get from 7 upward. So again, the apparent domain is still kind of an interesting one, but nope, domain is still going to be only 7 to infinity. Questions on that? Does it make sense how to see the domain of the resulting function? We take the two parent functions and the composed function, and what is the most limits we can impose on it? And that's what we're taking, the strictest limit we could possibly impose. Let's do another one of these. All right, write this down if you would. F of x is 2x minus 5. F of x is 2x minus 5. G of x is 2 over x minus 9. G of x is 2 over x minus 9. And we're going to find g of f of x. G of f of x. All right, one more time, Maddie. How do we set this up? I'm sorry, say what? Well, we're not ready for that yet. Just say g of... There we go. And then that becomes
2 over x9.
We're replacing the x, remember.
2x negative 5 minus 9.
Right. So g of f of x means g of 2x minus 5, which means 2 over 2x minus 5 minus 9. Where this becomes that. All right, we can simplify a little bit here, though, so let's go ahead and finish the simplification, Abby.
2x minus 14.
Right, 2 over a 2x minus 14, and then that
becomes 1 over x minus 7.
Good. Factor out a 2, cancel the 2, we end up with a 1 over x minus 7. All right, let's look at our domains. Thoughts on f of x, class?
All the numbers.
All the numbers. You can plug in anything you want. It's a linear function. This one.
All the numbers except 9.
All real except 9. All right, now let's look at the apparent domain here.
All the numbers except 7.
All real except 7. All right, so if we're looking at the number line here, here, and here, this number line is anything. This number line is almost anything, but that 9 gets left out. This number line is almost anything, but the 7 gets left out. You have to account for every limitation. Well, now there's 2 separate limitations. So for my actual domain, we're going to say the domain is all real except 7 and 9. Does that make sense? It looks like just 7's ruled out. But because you couldn't use a 9 in one of the parent functions, you can't use a 9 here either. Does that make sense? Just accounting for all the limitations that pre-existed and now exist continually. Questions on that? Yes, ma'am.
What if one is like only positive 7 and up, and another is like only negative 7 and down? If they contradict each other.
Okay, so let's suppose, so you said, let's suppose one of our domains is 7 up. The other is negative 7 down, or rather negative infinity, negative 7. And the other domain is
4 and up.
4 and up. All right. Well, obviously the 7 and up is ruled out here, right? Can't include 7 and higher. But the negative 7 and down is included there. 4 and up is obviously also cut out by this one. So there's literally no entries. You couldn't use the function. It's a worthless function now. Because everything has ruled everything else out, right? There's not a value it can fit in all of those, right? You're like, well, what about 9? Nope. What about 5? Nope. What about negative 3? Nope, right? So there's literally no values you can plug in. Your domain is now completely empty. You have no more function.
Okay.
But theoretically, yes, that would be the answer. Okay. All right, let me take another theoretical here that's maybe a little less extreme. Let's suppose we had a range here that's, let's say, 2 and up. Let's suppose we have another one that's negative infinity up to 5. And let's suppose we have another one that is negative 1 and up. What values actually fit all of those? Only between 2 and 5. Anything bigger than 5 is ruled out. Smaller than 2 is ruled out. So the resulting actual domain would simply be between 2 and 5. That make sense? Does that help you understand kind of your question as well? All right, in fact, our next problem I think is going to be somewhat similar to this. Write down this function for f of x. F of x is the square root of x minus 3. F of x is the square root of x minus 3. G of x is negative x plus 9. G of x is negative x plus 9. And we want to find f of g of x. And in just a moment I will catch up. Again, it's not quite the word fog. Okay, the O is small and it's raised. It's a little circle there, raised up. All right, Genesis, how do I write out the function f of g of x?
F times
Of
f of negative x plus 9.
good.
And then square root of negative x plus 9 minus 3.
All right.
And it's going to be negative x plus 6.
Good. Now I could write negative x plus 6, or I could flip-flop and say 6 minus x. That makes sense? I kind of like 6 minus x, to be honest. Questions, comments so far? All right, let's figure out the domains here. What's my domain on f of x? 3 to infinity. You plug in anything smaller than 3, we're in trouble. So 3 to infinity is what we got. All right, what about g of x, class? What remembers, it's a linear function, anything you want. What about here?
6 to negative infinity.
Yeah, 6 is your biggest number you're allowed to plug in, right? You plug in anything bigger than 6, you're in trouble, so negative infinity up to 6. So, number line, number line, number line. Three to infinity. Anything you want. Negative infinity up to 6. What's the actual domain going to be?
3 to 6.
Only 3 to 6. Nothing bigger than 6. Nothing smaller than 3. So, very limited function, isn't it? Your only outputs are from the square root of 3 up to the square root of 0, or square root of 0 up to square root of 3, I guess. So not a whole lot of answers you're going to get out of that because of limitations that present themselves. Questions on this? Feel like we got a handle on it? All right, then let's look back at your homework again. And let's look at what the domains would have been on numbers 1 through 9. The teal. Go take a look at the homework again, 1 through 9 in teal. And let's see what we should have had for our domains. Again, you didn't have to do the domain, okay? But had you done it, did anyone try the domains just to see? Okay, the guys did. Way to go, brave gentlemen and ladies. I won't hold it against you. All right, so number 1, I'm going to use the answer key here just to see what the functions were. So number 1, f of x was 3x plus 5. G of x was 4x squared plus 6. We found that f of g of x was, where is it, 12x squared plus 23. That was earlier in the video if you want to go back and rewind to fact check me. And then in just a minute we'll address g of f of x, which we found to be 36x squared plus 120x plus 106. All right, domain, all real. Someone besides Brady can answer. Domain class, all real numbers. Apparent domain, well, it's like Adam and Eve. Like they had no issues with their DNA and their kids had, anyway, no issues at all, right? So the domain really is all real numbers here, right? Because there's nothing, no limitations anywhere. What about the apparent domain here? Yeah, so number 1 was an easy one. All the domains are all real numbers. Okay, so that was kind of a letdown. Number 2 is going to be the exact same way. I'm just looking at number 2. There's not going to be any limitations there either. Okay, let's go to number 4. Number 4 has some limitations. All right, f of x. Get on the right page. Number 4, f of x was a negative 3x squared minus 9. G of x was a square root of negative 4x positive 8. F of g of x was a 12x negative 33. And then g of f of x was the square root of 12x squared plus 44. All right. Domain. All real numbers. You can plug in anything you want. Here, let's think about the domain for a minute. What's the biggest number you can put right here? 2. You put a 3, you're in trouble, right? Negative, though, you're fine. Anything negative is good, right? So how would we say 2 is the biggest? Here, apparent domain. All real numbers. But this is the only limitation that presents itself. That's the domain. Here's a tricky one. Apparent domain. Well, anything you plug in here when you square it is going to become times 12 is going to be even more positive, plus 44. So is there anything you could plug in that would be a problem? You can plug in anything you want. This domain is also all real numbers. Again, we're discounting imaginaries here, but all real numbers. So again, since the only limitation is presented here, that's also going to be the domain here. Does that make sense? Questions on 4. The domain thing's starting to make more sense to you than it did yesterday, surely. Yeah, I felt like at the end of the video, I'm like, I don't know that I explained that too good, but I don't know how else to explain it. Anyway, number 5. F of x was an 8x plus 11. G of x was a 1 over, this was the weird one, negative 2x plus 12. We found that f of g of x was negative 4 over x minus 6 plus 11. And then later we found g of f of x was negative 1 over 16x plus 10. Okay? Domain. Or numbers. Here, x just can't be 6. All right? Here, what appears to be the domain? Everything except 6. Well, everything with 6 and all real, what's the domain? Everything but 6. All right. Here, tricky. What's the domain? Can't be negative 10/16 or negative 5/8. So if it can't be negative 5/8, can't be 6, can't be real, then what's the domain? Everything but negative 5/8 and 6. Right? We just have to account for that extra domain issue from earlier. Questions on 5? Anyone happen to have that? It makes sense now. All right? Number 8 is just going to be all real everywhere because there's no limitations on anything in 8. Number 9. By the way, do you all see, as you look at number 8, you see why I can tell by looking? There's not going to be any limitations. All right. Number 9 is no in German. All right. F of x equals square root of negative 2x plus 12. G of x equals negative 3x squared minus 9. We found f of g of x to be square root of 6x squared plus 30. We found g of f of x to be 6x minus 45. Domain.
Negative 286.
Can't be bigger than 6. Y'all see it? All right? Here. Apparent domain here. All real. No matter what you plug in, you're going to be fine. So what's the actual domain? Negative infinity to 6. All right, apparent domain here. All real numbers. So the actual domain, negative infinity to 6. Does that make sense now? Questions on the domains we would have had for the homework. All right. Homework for this evening is to do page 210, 13 and 14. Page 210, numbers 13 and 14. That's at the bottom of the page. And page 220, numbers 29 to 34. Page 220, numbers 29 to 34. I will take a look at all of this in our next lesson, and hopefully as you try the homework tonight, things will finish making sense to you, but we'll go over them tomorrow to make sure. Have a wonderful rest of your day, and you are dismissed.